So we're really excited to hear from you today. I think I gave you a little bit of background on the native seed testing issue here in the state and how that's affected our native seed industry and our native seed consumers. And so we're really excited. I kind of was over the moon when I read this article in, I think was it Seed Today? It was in one of the like industry publications, yeah. And I have to tell you, I get completely thrown by all of the acronyms. So there are the organizations that oversee seed analysts, right? Or their organizations, professional organizations of seed analysts, and that's like AOSA and there's the other one. SCST, okay. And then there's the organization that oversees like the source identified seed and that kind of labeling, and that's AOSCA, right?
But yeah, Association of American Seed Control Officials.
Okay, perfect. And then you're with you were on the board of the organization that did this native seed lab uniformity study, and that's okay. All right. So there's so many acronyms in this, but what's really exciting is that we have these national organizations that are looking at this issue, who are saying, okay, this is problematic, and we need to understand it better. And you're actually doing the research into that. So sorry, I'm talking too much. I need to turn it over to you because it's your turn. It's 10 o'clock.
Okay, so I'll start here. It's the ASTA, this is the American Seed Trade Association, and AOSCO, American Association of American Seed Control Officials uniform study. So let's just get going. All right, let's try this again. There we go, okay. So I just wanted to give a little background, a little timeline on this. The issue of uniformity has been discussed for a long time. It's been an issue that's come up over and over again. But in this latest round, it began back in June of 2019. Jason Goltz, who was at the time the vice president of the seed control officials. At the time, I was the president, but I had other duties to attend to. So we asked him to come along so that he could participate in this and also increase our connection there with AOSA, which is the Association of Official Seed Analysts, and SCST, which is the Society of Commercial Seed Technologists. Those are sister organizations, regulatory and the private side of things. So during that discussion, again, uniformity came up. There's a lot of concern around it. Then in July of 2019, at the Seed Control Officials meeting, we talked about this issue. We talked about issues of laboratories which seem to report very high germs. So we decided we'll move forward with a blind study. And ASTA liked this idea, and they agreed to be part of this. So in August of 2019, we got ASTA members to donate seeds, and they were prepared by a registered seed technologist. This is someone who's certified in germination analysis and purity analysis. So samples were delivered to the samples that we altered, and we knew what we were sending out were sent to the ASTA members to redistribute to seed testing labs. And then October through December, we received the results back, and the RST began logging that information. Then early 2020, we got a statistician on board to analyze all the data. And then in June, all that data analysis was finished. And then in the summer of 2020, we reported our findings to ASTA and AOSA and SCST. So this is going on about 2 years now since this was completed. Give a little background on the study. We had ASTA labs agree to participate and supply the seeds. We chose 12 seed testing laboratories, some at random, some on purpose, and it was a mix of private labs and regulatory labs. The seed was sent to the registered seed technologist, where a baseline purity and noxious were established. So they got the lots in, they took the lots and divided them into subsamples, those 13 subsamples. And one of those subsamples was then very carefully analyzed to create that baseline information that we needed to see if the labs would be in tolerance or not. The RST determined which contaminants to add to each sample. We wanted the different seed kinds involved. You wouldn't want to add a contaminant that made no sense for it to be there. So using their past experience with the seed, they put in contaminants that would be reasonable to find. Like we said, the AOSA sampling and dividing procedures were used to generate the subsamples. So this is a statistically based procedure that should give a representative subsample of the entire sample that was submitted. The contaminants were then added, and then those subsamples were set out to the companies with instructions on how to submit it to the seed testing laboratories. One sample of each of the following species were sent to each laboratory, so you can see the list there. I won't necessarily read it all off. In hindsight, it may have been better not to send such a diverse range of seeds, especially if maybe it was something that a company didn't regularly test, because as a seed testing laboratory, which I run the seed testing laboratory in Pennsylvania, if I received from a company these 12 samples, I'd be like, wow, this is unusual that a company does this. So we may have inadvertently raised people's concern a little bit about why they're getting these types of samples. And we're really hoping for a blind study. So, I mean, it is what it is. It's done and over with, you know, hindsight's 2020. But this is the list of seed kinds that were sent to the seed testing laboratories. Again, the labs were not aware that these were altered samples, although they may have been a little concerned about why they're getting these types of, this wide variety of samples, and maybe questioning why these samples came from a particular seed company. But they didn't, but no one was made aware that these were altered in any way, that this was a blind study. When the company received all the lab reports back, they forwarded them onto the RST. The information from the reports was compiled, and then this was given to a statistician for analyzing. So the general approach, we wanted to look at the variation among the labs for each species tested. We also wanted to assess the overall performance of the lab across all species. And we were hoping to minimize or remove some of the variables. I'm not sure we did the best job on that entirely. Again, you know, first time through, it's a learning experience, in hindsight is 2020. Specifically, we wanted to look at variation among the lab reports as compared to the expected information. So were these labs in tolerance of the baseline purity and analysis, noxious weed analysis that we found. We also wanted to look for variation between lab reports as compared to one another. You could have a maybe something in the baseline or the sample was extremely difficult and all the labs missed it. Well, this would tell you around a tolerance with the baseline, but if everyone missed it, then it won't lead to non-uniformity. Everyone would be uniformed in the response. So we wanted to look for those differences. And we also wanted to see if there was any labs that would be noticeably an outlier for any specific test or maybe for a specific species. So with that in mind, when the analysis came back, this says purity and inert here. You can think of this as a purity analysis. We found that the purity analysis was rather quite good. Based on the analysis of variance, overall samples tested and overall samples tested, there was no significant difference among labs. So this was very good to see. Now it says here there was no single lab was considered an outlier. That said, this is a statistical analysis. You know, this is all formulas. But when you go through the data and you look at it, we did notice that there was one lab that tended to be pushing the envelope more than others, but statistically still within tolerance. The one species that we did have, we noticed a problem on, that there was you know, variation beyond the tolerance, was with big blue stem. Now, if you've ever worked with blue stem, big blue stem, this is not necessarily a surprise. It's very difficult to identify the pure seed unit within blue stem. Unless you work with it on a regular basis, unless you're very familiar with it, this one will trip you up. I've done blue stem purities that taken me, you know, almost 2 days to accomplish, because it was so hard to tell what was a pure seed unit and what was inert, you know, inert matter. So it's expected, but it's a great opportunity for improving. And it, you know, this highlights that this is one that we need to put some effort into and we need to improve on. But it, again, purity analysis was pretty good. Germination and TZ. Now, the germination came back a little disappointing. There was variation here, especially in the small seeds. Again, few outliers, but no single lab was consistently an outlier. Again, we did see the one lab kind of pushing the envelope more than the others, but again, based on the formulas, it's still within the tolerances. But germination was out more than it should have been. That's just how it is. And TZ results were very inconsistent. TZ, though, this isn't very surprising. TZ is fairly hard. If you're working with small seeds, let's say like a Kentucky bluegrass was in the study, to do a dissection of that, to get it stained properly. I mean, that's just almost like physically demanding to do that kind of test. So the harder the test is, most likely you're going to have more variation. So we need to improve the germination, and TZ, although kind of expected there would be inconsistencies, it's an area that needs to be improved, but not surprised by it. Okay. Contaminants. Now, this is the area where the study kind of was the most worrisome. The study showed a significant deficiency in the ability to detect, identify, and classify contaminants. In a fair number of samples, contaminants found were lower than spiked, and at times the contaminants were undetected. So this means we need to definitely work on the skill to identify seeds, to be able to detect seeds. Also, the classification of the contaminants was off. This is an educational component. It's simply taking the time to read the rules and go through the noxious weeds list properly. But still, it indicates something that needs to be worked on. And again, this was the worst information to come out of this study. But I do want to temper it a little bit by saying that the subsamples that we sent out, we didn't do an empirical analysis on those subsamples to know precisely what they were getting. We had a very good idea of what they should be getting, and they should have been within tolerance. And the fact that they weren't within tolerance is disappointing. Also, when a sample is received, you have to run it through a mixer divider to get a subsample, which is a working sample that's still representative of the sample you received. And so we don't know exactly the empirical content of that subsample. So it is bad, but perhaps not as bad as it seems, but it is definitely an area that needs to be worked on. ROA stands for Report of Analysis Compliance. In general, they did pretty well, but there were numerous inconsistencies, deviations, ambiguities, and a lack of updated information related to the implementation of the rules. So this kind of is still part of uniformity, in that if things aren't being reported consistently or properly, this can lead to confusion and not getting information correct. Inconsistent listing of germination testing conditions. Part of that is that not everything that you could list is required to be listed by the rules. So you could still be following the rules and report things quite differently from another lab. Dormancy breaking methods were not reported. They're supposed to be reported. Things like this we could work on improving, and that would help just understanding the information better. Okay. So conclusions and recommendations. Purity analysis seems to be consistent among labs, and results do not indicate excessive variation. So we're pretty good there. But we still need to work on seed identification and proper classification. Germination testing had a high degree of variability among labs for many species. TZ results were extremely high, and the noxious weed examinations included more out of tolerance results and misclassifications than is acceptable. So these three areas, the germination TZ and the noxious weed exam, we need to really work on those. And we also need to work on the report of analysis. So I threw in, considering the audience, I threw in some other information that we might want to consider and to keep in mind. Seeds of highly chaffy seeds are difficult to perform a purity and germination analysis on. The harder it is to identify the pure seed unit, which is the unit that has to be planted in order to get the germination percentage, the harder it is to do your purity and to get a good germ. That's not necessarily an excuse, but in cases of highly chaffy seeds, this does pose a challenge. Also challenging is that a lot of highly chaffy native seeds are often not homogeneous. The lot isn't, which makes it difficult to obtain a representative sample. And if you can't get that representative sample, you're not going to be able to get uniform lab results. Again, an area to work on, an area to improve. And then I would, we need to think about most of the seeds tested from a regulatory point of view are within tolerance of their labeled claim. So most seed control officials experience that between 90 and 95% of the labels that are checked are within tolerance. This means then a seed company tested the seed, they provided results, and the seed company labeled on those results. The regulatory agency checked it, and 90 to 95% of the time, they're in agreement. So I think one of the weaknesses of this study is, as we relay this information, is we called it a uniformity study. Well, if you think about what I just said, if we're at 90 and 95% uniformed in our testing, we're finding the same things. That doesn't seem like this is really much of an issue. And in fact, during our meeting with the seed control officials, the motivation for the study was not so much concern about lab non-uniformity as much as it was a concern about fraudulent activity. Reporting, overly high germination results was one of the main reasons given for this study. But, we have to be considerate. We don't want to say this is a blind fraudulent study. So it's a blind uniformity study. And of course, as a seed company, if you get a report that says your label is way off, that's going to stick out way much more than, or way more than when you're in compliance. You might not even get a notice when you're in compliance. So it's just something to consider and to be aware of. From a seed control official's point of view, we don't see non-uniformity as that great. But again, this study did show some deficiencies, so we need to work on those. And then I'll finish this section with saying higher germination results are not better results. Accurate germination results are better results. When you have a test date, it is given a period of time in which it is good. Let's say 9 months. A lot of seed is good for 9 months. So within that 9 months, what can be expected of the seed? If your seed had a lot of dormancy, maybe the dormancy breaks and you could see a slight increase. If your seed is excellent quality, you would see it stay the same. But depending on the quality of the seed and the species over that 9 months, you would expect that germination to drop. And this is what happens with most seeds, it drops some. But by the end of that period, it should still be within tolerance. But after that period, then you need to get a retest to reestablish that germination percentage. If you're labeling accurately that whole period, that the 9 months that you're allowed to sell the seed, it should stay within tolerance. If you're overstating, 2 things happen. One, it'll drop. The drop is going to appear to be greater because the tolerances are smaller. The closer you get to 100%, the tolerances get really tight. The closer you get to 0%, the tolerances get very tight. 50%, that is the widest tolerance that we have in that range. So if you overstate, you're going to reduce your tolerances, which is going to make it appear like you could fall out of tolerance much faster. Accurate labeling of the germ is really important to keep that seed on the shelf and keep that seed moving. We don't want to see a disruption to that. So these are just some thoughts, some things to keep in mind. So the response to this study, AASCO put this out there. We did not tell anyone what to do, but AOSA and SCST, in response to this information, have formed 4 working groups that have begun developing learning and training opportunities. The working groups are Germination, TZ, Purity, and the report of analysis. The Purity one is also going to include the seed identification and noxious weed portion of it. So doing a noxious weed exam. All of these committees have been working very diligently, and they're coming up with proficiency testing, and they're coming up with new training opportunities. They're coming up with, like the Germination is trying to move towards photos of seedlings to help improve that. So as from AASCO's perspective, this was great. This is very good. The seed control officials, one of the things that we push and we say all the time is we can't have uniformity if we're taking samples differently. So we all have to be taking samples the same. And to help with that, we've moved our basic seed sampler training online. So you can go online and take this exam. There is a cost to it to cover, the administration of the exam. We also, with that, give out our seed sampling handbook. And if you pass this exam, if you get this, it will demonstrate that you know where the information is or how to get the information to take a proper sample to submit to a seed laboratory. Again, this is where the seed control officials feel that we can really help with the uniformity, is by promoting this and getting as many people on the same page to get that representative sample. And also moving forward, the seed control officials could possibly do another blind study. They're expensive and they're time consuming, and you have to find the expertise to do it. And of course, we've already done one, so you know, to make it a blind study, we'll have to be very careful how we design it so it doesn't tip anyone off. But that possibility still exists, but we'll see. And with that, I'm finished. I'll stop sharing my screen now.
Okay, thank you so much. It was really helpful to have that explanation even after having read that short article on this. We have some questions from the audience.
Sure, thanks, Johnny. That was great. I would encourage you to do another test, and I would encourage you to increase the volume of native seeds that you test. I saw really only one persnickety one on that first list, and I'd like to see 6 or 7 of the more difficult seeds to test on that list for the next round.
Were you able to hear that okay?
Yes,
that
I
okay?
was. Is there, would your group like to get a suggestion of what those species would be to me?
In the moment, that might be a little difficult. I'd like to consult with my team, but yeah, we'd certainly would be happy to do that.
You can easily find my contact information online and just email it to me.
Yeah, and I'd be happy to mediate that if need be, since we're in touch. A question here?
Yeah, I was just...
Hang on for the mic. You. Yeah, there you go. Thanks.
I just wanted to mention differences with different ecotypes of native seed species, or I mean, within, different ecotypes of individual species of native seed, particularly relating to dormancy breaking methods. And like current standards, a lot of them are just, they just go right into a warm stratification. And, you'll see these massive swings depending on, the seed source and all that. For example, warm season grasses that are cultivars versus local ecotype from further north you go. It's probably more prevalent, but we're up in Minnesota, and if you don't do a warm, or I should say any moist stratification on even common, like Indian grass, big blue stem, you will have potentially 8% germ and all the rest dormant, and you throw it in 14 days and it'll completely flip the other way, and you'll get 80-some% germ and 7% dormant or something like that. And so, people will say, oh, that stuff's blah, 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 but that's a survival strategy for something to fall on the ground in the fall. And, the cultivars maybe, a lot of times germ right away because we selected them that way. They bred them to be fast, bang, 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 you plant them right away. And I've also heard about them rotting when they plant them in the fall. You can't do a dormant planting, they rot. Well, RC doesn't. It's got a survival strategy to get through the winter in moist soil. So anyway, but it does show really big differences, and I don't know how that could be addressed, but.
I wonder if that is related to the labeling of those dormancy breaking methods, and would that be addressed by some of that, more consistent labeling, so that you understand what has been applied? To make the results more comparable,
Well,
perhaps?
yeah, I mean, I don't know, it probably has to be one standard for, grasses, but I don't know if there's just, I guess, there's an ignorance in just the general public and, buyers, and they'll look at this and say, oh, what, and they don't realize why there's these differences. I don't know how that can be addressed in standards, or if there's options for 2 different methods. You can either do, a dormancy breaking of, no dormancy breaking, or a standard dormancy breaking of some sort, which would be still 10 times better than just throw her in the old dorm chamber right away and hope for, desirable germ versus all dormant. So.
Yeah, the natives are quite difficult with that. There are field label within SCST. he works quite extensively on natives, and there is the seed analyst and the seed technologist acknowledge that there's a tremendous amount of work and opportunity here with those. And I think you're right too, there needs to be an educational component to the consumers, but who does that, how we get that out, I'm not exactly sure either.
Yeah, excellent questions. We've had Gil Wabel's been here before and talked with us about the rule development process for native seed, so that was really interesting as well. But yeah, we've got another question.
So his question made me think, surely they have this all in the rules based on ecotype. They're actually paying attention to that, Johnny, when they're looking at the rules for all of the testing and everything. It's kind of by ecotype and these different methodologies, dormancy breaking methods.
Yeah, there's not too much concern to ecotype, and that may be an area that needs to be developed, but right now it's by seed kind or by species.
Yeah, so maybe, so maybe they need to break it down even further based on like the ecotypes that allow, do more the moist stratification or something else down south where it's drier. Whatever that may be, I'm not an analyst, so I can't tell you what that is, but yeah, okay.
But I think 2 different options might be workable. As long as it's listed on the report.
Right, the uniform labeling is something that seems like it would really help the consumers at least to be able to evaluate those reports. Other questions? I guess just a big thank you to joining us and preparing this presentation and joining us today. It's really great to know that those organizations are working on these questions and are open to hearing from people on the native seed side of things where we are really difficult. It's the nature of the beast that we work with. We're going to ask difficult questions. So thank you so much.
Yeah, and it was good to hear from you, and I was taking notes, and I will report all of this back to the seed control officials, the AOSA, and SCST.
Thank you very much for that. And you're welcome to hang around and listen to other presentations this morning if you have the time. But we just want to thank you again and for joining us today. Can you hear us clap? Okay, all right. Well, take care and enjoy your beautiful weather.
Thanks.
Okay, bye-bye.